What if you were given a length of copper wire so short that when it is placed onto a balance, the mass can't be measured because the balance still reads 0? The wire must have mass, but the balance is just not sensitive enough to register it. So you would need to come up with an alternate method to determine the mass of the wire. To find the mass of the wire, let's look at a short experiment. The materials needed for this experiment include an electronic balance, multiple lengths of 18-gauge copper wire, a ruler or meter stick, and a caliper. The lengths and masses of the longer pieces of copper wire should be measured. Let's look at the masses of the pieces first. Sample 1 has a mass of 0.3 grams. Sample 2 has a mass of 0.4 grams. Sample 3 measures 0.7 grams. Sample 4 reads 0.9 grams. And sample 5 is the heaviest at 1.3 grams. Digital devices like the electronic balance used in this experiment have an uncertainty which is equal to plus or minus the smallest possible non-zero measurement the device could register. The balance used in this lab has an uncertainty of plus or minus 0.1 grams anytime it is used. This means that the masses we just looked at are not exact, but should be close to the true mass of the samples. To have an idea of what the true mass of a sample is, we calculate a range by subtracting the uncertainty from a measurement to find the low end of the range, and then adding the uncertainty to the measurement to find the high end of the range. Let's consider sample 3 as an example. Since this piece of wire was measured to be 0.7 grams plus or minus 0.1 grams, the true mass of this sample of wire would actually fall somewhere between 0.6 and 0.8 grams. The next step is to measure the lengths of the copper wire samples. This is done using a meter stick, which is an analog tool. Uncertainty of analog tools is found by performing a simple calculation. The smallest increment of the tool is divided by 2. Since the smallest increment of the meter stick used in this lab was 0.1 centimeters, the uncertainty is found by dividing 0.1 centimeters by 2 to find an uncertainty of plus or minus 0.05 centimeters. The wire samples were measured as follows. Sample 1, 1.95 centimeters. Sample 2, 3.75 centimeters. Sample 3, 6.35 centimeters. Sample 4, 9.00 centimeters. Note that this measurement must be recorded to include 2 zeros after the decimal, since the uncertainty goes 2 places past the decimal. And sample 5 measured 13.15 centimeters. A range for each measurement can also be calculated by subtracting and adding the uncertainty of the measurement. For example, the true length of sample 2 lies between 3.70 and 3.80 centimeters. Now let's look at one more measurement tool. A caliper is a tool used to measure lengths that is more accurate than a ruler or a meter stick. To measure the tiny piece of wire, the sample is placed in the lower jaws and the thumb screw is turned until the jaws close on the wire. The position of the zero line of the vernier scale is compared to the main scale. For this sample, that falls between 0.2 and 0.3 centimeters. To finish the reading, you will need to find which increment of the vernier scale lines up most closely to a line on the main scale. Each increment you go over adds 0.01 centimeters. We start at 0 and go up 1, 2, 3, 4, 5 to find where the lines match best. This means the copper wire has a length of 0.25 centimeters. The uncertainty of the caliper is also found by dividing the smallest increment by 2.
0.01
divided by 2 equals plus or minus 0.005 centimeters, which means our tiny length of wire has the true length somewhere between 0.245 and 0.255 centimeters. To determine the mass of the unknown sample, a graph plotting mass in grams on the y-axis versus length in centimeters on the x-axis can be prepared. The data from this experiment will follow a linear relationship, and a linear regression analysis can be performed using Microsoft Excel, Google Sheets, or a graphing scientific calculator. I will cover the steps of performing a linear regression analysis for this data in a separate video that I will link at the top. Thank you for watching. I hope you found this helpful.